Welcome again to our continuation part of the topics of Form 4. We are now today switching for the new topic. This one is referred to as a vector. Have you ever come across with the term vector? Definitely in real life situation, you have been dealing with the vector either unknowingly or being aware. So what we say at the end of this topic, what you need to know, what concept you will need to be competent enough with the topic. You will need to know the meaning of vector and the definition itself. How do we denote vectors? And we will also have to know the concept of equivectors, the idea of opposite vectors, the concept of vectors in the coordinate system, also called the positional vector, which is the special name. Also we'll have to reflect the idea of component vectors, as well as a part of operation on the positional vector, as well as properties of vectors, vector addition and scalar multiplications, what properties holds with such kind of vectors. And we will have to know the concept of I and J unit vectors, operation of I and J, modulus of a vector called magnitude of a vector. Also we'll be checking the part of unit vector and the direction of the vector. We'll have to know the idea of directional cosine and the directional ratio of vectors. And then we will be concluding with the application of vectors in real life situation. We will learn how you are supposed to sweep when the wind is blowing this direction. The wind is blowing this direction. Where are you supposed to stand? How can you close the lever where the water current is moving fast? Which trick are you going to make it? So this is the competences in which one will have to be competent enough upon dealing with this topic of vectors. So starting with the introduction part, we say some quantities needs only a number so as to express them fully. For example, distance, or you want to look for the length of this ruler. You just take the measuring from this point to this to know the dimension of this one. The area of something else, or of a place, or of a field. You want to check the volume. Things like those ones are always expressed only their magnitude. So such quantities are referred to as scalar. But quantities which need to be expressed by using both magnitude, I mean size, and direction, and their direction, considering a fired bullet, let's say, such things we call them as vectors. So we can be giving the definition. So we say examples of vectors here, things like force, velocity, displacement, momentum, and things like these, which requires magnitude and directions. So we want to check now the definition of a vector and a scalar quantity, in which we say a vector quantity is that quantity which needs both magnitude and direction so as to express them fully. So there must be a magnitude and a direction so as to express them fully. But quantities which needs only numbers to be expressed fully, we call them as scalar. So notation of vectors. We always denote the vector by using an arrow which indicates the direction of a vector, but where the vector comes from. So for example, when you're using this figure here, it means we denote A and B. We say the vector is moving from A to B, and then this arrow is a direction where the vector starts, where ends. The position where the vector starts, this is a one referred as a tail, or initial point we call it. And the end point where the vector is heading is the one called it terminal point, or simply head. So we say, we write as vector AB, and using this symbol here, which is the symbol for vectors. Which is the symbol for vectors. A letter where the vector starts must be starting first, and where the vector ends must be the end to read the vector. Small letters are also used to define the vector. So here, for example, the vector here, we're going to be using small letters like this. We could be defining it by choosing any letter. We say small letters could be also used to define the vector. It will be used to name the vector. So we say thus, from above, let us use a letter B. So we could see the vector could be presented like this. We could simply present the vector here with arrow, and this letter B indicating the vector starts from this point to this point, which also signifies the same concept of denoting the vectors. So you can see how it really works with this concept. Now let's look with the other part of the topic. Let's check this. Okay, so we say we want also to look with some types of vectors given their names. We have this one is called as eco-vectors. Two or more vectors are said to be equal if they have the same magnitude and points into the same direction. So we say these are vectors with same magnitude and direction. So you have vector A and vector B. They all point the same direction and also have the same magnitude. So magnitude S and S. The size of vector A is S and the size of vector B is S. And also all points in the same direction. So we write vector A equals to vector B. But performing algebraic operation here, upon taking B to the other side, becomes vector A minus B equals to 0. So we call them as eco-vectors. Therefore, vector A is equal to vector B. We call opposite vectors. Opposite vectors, these also called negative vectors. These are vectors in which they have the same magnitude but points different direction. So the word opposite vector also referred as negative vector. That means, that is to say, negative sign in vector signifies opposite direction. So you check this vector A and B. Vector A points this direction while B points this direction, but all have the same magnitude n. So we say vector A equal to negative vector B, in which you bring B to this side becomes positive. So we say A plus B equals to 0. In that case, the two vectors are referred to be as negative vectors. So negative vector, we say negative sign signifies opposite direction. Then we have vectors in the coordinate system. In the coordinate system, when given vectors, we all start measuring vectors from the origin. Also, so all vectors start from the origin in the coordinate system. So when you want to define vectors in the coordinate system, also called the position vector, which is their other name, we always read at the TED, at the terminal points. So only the terminal point is considered. Only the terminal point is considered. For example, looking vector A, they all originate from the origin. So only the terminal point. So vector A equals to 2, 2. Vector B is 3, 0. Vector C is 3, negative 1. Vector T is 0, negative 2. Vector Z is negative 2, 0. Vector N, negative 2, positive 1. Vector R, negative 1, 1. So all vectors in the position of vectors in the coordinate system only determined by checking the head or the terminal point of the vector. So you can see here we have tried to define all of them. Now there is a concept of components of vectors. Component of vectors. Let's consider one vector P, which P is A, B. But we say to get this position of vector P, there is the horizontal part, which is A, 0, and there is the vertical part, which is 0, B. And then, so coming to this is when you get this vector P. So we say any vector is a result of the sum of horizontal component and vertical component. That is to say, the next topic of Form 4 series of topics. We are now switching the topic of linear programming. This one as the topic itself, linear programming. So at the end of this topic, we need to have the concepts of the historical background of the topic.